So this question, which is related to formula moles and the amount of a substance, the correct answer for this one is D. But how D is the right answer, I will discuss. Look, in the question, in an experiment carried out at 200 degrees centigrade at 1 atm, 20 cm cube of ammonia gas reacted with excess of a copper 2 oxide. So this is an excess reagent, so we don't have to look for it. Because whenever we find a product, we always find the product from the limiting factor or limiting reagent. And when the volume is given, the mole ratio and the volume ratio is always same. So if all measurements were made, what would be the total volume of a gaseous product? So what are the gaseous product? We have water vapors and we have nitrogen. So what is the ratio between ammonia and water vapors? That is 2:3. So if ratio is 2:3, 20 will be X cross multiply. So how much water or what is the volume of the water vapor? It will be 30 cm cube. Because when volume is given for the mole for the gas, you just take a ratio, mole ratio. Same thing, what is the ratio between ammonia and nitrogen? Like the ratio between them is 2:1. So if you have 20 cm cube, this will be X cross multiply. So you got 10 cm cube. So means 10 cm cube of nitrogen and 30 cm cube of water vapor. So what is the total amount of the gas or a gaseous product? That is equals to 40 cm cube. Is it clear, this method? So in this question, we have ammonia is manufactured from hydrogen and nitrogen in a Haber's process. If 60 tons of a hydrogen produce 80 tons of ammonia, so this is a practical value. What is we need the percentage yield. So what is the percentage yield? Percentage yield is a practical value of a product divided by theoretical value into 100. So practical value is 80, but theoretically how much we should get? So we can take a ratio between hydrogen and ammonia. So according to the ratio, the 3:2 is the ratio. So if I have 60, this will be X cross multiply. But this is a mass is given. So for a mass, you have to convert into moles as well because the practical value is given 80 turns. The practical, because ton is a unit of the mass, so I have to first find the moles. How to get the moles? Moles equal mass in gram divided by molar mass. So example, mass in gram. If I'm taking mass in a tons divided by the molar mass of a hydrogen, which is 2. So what we'll get? We'll get 30 tons or 30 moles per ton or 30 tons per mole, I mean. That is a hydrogen. Because when the mass is given, I have to take a, like, I can take a I cannot take a mole ratio with a mass ratio, so I have to convert them into moles. So this will be 30 tons per mole. And what about ammonia? So the ratio between them is what? The hydrogen and the ammonia. As you can see, 3:2 is a ratio. If I have 30, this will be X. Cross multiply. So when I cross multiply, 30 into 2 will be 60 and 60 divided by 3, that will be equals to 20. So means I will get 20 moles of ammonia, but I don't need the moles of ammonia. I need the mass of ammonia. After getting the moles of ammonia, I'll multiply by the molar mass. What is the molar mass of ammonia? Nitrogen is 14 and hydrogen is 1 into 3. So total is 17. So 20 multiplied by 17. So I'll get 340. So the total, like theoretical mass will be 340, but practically is 80. So 80 divided by 340 into 100, that will give us the percentage yield of this ammonia. So why I cannot take directly the mass ratio and mole ratio, because the mole ratio and the mass ratio is not same. So if the mass is given, what I did, I first convert into mole. And then I took a mole ratio to get the moles of ammonia. And after getting a moles of ammonia, I multiply by the molar mass to get the mass of ammonia. So practical value divided by theoretical into 100, we got the percentage yield of this ammonia. Is it clear, this question? The formula for concentration in parts per million, ppm, is equals if the mass of solute divided by the mass of solution into 1 million. So a solution contains 33 ppm. So concentration is given 33. The mass of a solute dissolved is 1 kilo. The mass of we need the mass of a solute which is dissolved in 1 kilogram of solution. So 1 kilogram of solution means 1000 gram. And the mass of a solute we don't know and multiply by 1 million. So we simplify. So this is 33. 1000 will be multiplied. So 33,000 divided by 1 million. What is the answer if 33,000 divided by 1 million? So 0.033 grams will be there. Or C will be the right answer. Is it clear, this one? So this is a formula for concentration in parts per million or ppm. Question 8. So the Avogadro's constant is equal to the number of Avogadro's constant means in which one we got 6.02 into 10 to the power 23 grams of an element which contain 6.02 exponent 23 atoms of the element. Atoms contained in 1 mole of any element. Look, element can be like Avogadro's constant, grams of an element which contains 6.02 exponent 23 atom. Element can be atom or element can be a molecule, can exist as a molecule. Like example, sodium is an element existing as an atom, helium an atom, neon an atom, but hydrogen is a molecule. Same thing, chlorine is a molecule. That's why this is not a complete definition. Atoms contained in 1 mole of any element. Again, element can be what? Element can be atom, element can be molecule. So this is not a complete description. Atoms contained in 1 mole of a monoatomic element. This is right. Like if we have a monoatomic element, monoatomic element means that only one atom is there which make an element. Like example, helium. So if we have 1 mole of a helium, how many atoms will be there? It will have 6.02 exponent 23. But if we have 1 mole of hydrogen, how many atoms will be there? It will be 6.02 exponent 23 multiplied by 2. Why? Because hydrogen is a molecule, so atoms will be twice of it. So that is the complete description. It's a number of atoms which are present in 1 mole of any monoatomic element. So C will be the right answer. Is it clear? The reason? Question 9. In which of the following pairs does each gas occupy the same volume? When gases occupy the same volume, they will have the same moles. So what we simply have to do, we have to find the moles for each. 2 grams of hydrogen. Hydrogen mass is 2. So 2 divided by 2 will get 1. 14 grams of nitrogen. So 14 divided by nitrogen is N228. So 0.5. So moles are not same. So it cannot be A. 32 grams of methane. So 32 divided by methane is carbon plus 4 hydrogen. So for 16. So this will be 0.5. And sorry, this will be 2 because 32 divided by 16. I thought, so this will be equals to 2. And 88 divided by 44 because the mass of carbon dioxide, so that's also 2. So if we have equal number of moles, it means the gases will occupy the same volume. About carbon monoxide, so this will be 7 divided by 28, which is 0.25. And this will be 16 divided by 32, which is 0.5. And hydrogen chloride, it will be 10 divided by 35.5, and sulfur dioxide 10 divided by 64. So B should be the right answer, in which we got the equal moles of the two gases. In an experiment, 3.42 grams of a lead oxide was reduced to form 3.1 grams of lead. Empirical formula. How to work out this? We have lead and oxygen. So 3.105 is lead. How much is oxygen? You subtract. So like 3.425 minus 3.105 will give us 0.32. So 0.32 is oxygen. What is the way of finding empirical formula? Divide by atomic mass. So first, using a periodic table, we'll divide this by atomic mass of lead, and we divide by atomic mass of oxygen. That is a step 1. Step 2, we divide by the smallest value in the combination. What answer we get? We'll get divide by smallest value. In step 3, we'll make a simplest ratio in a whole number. And if it is 1.5, 2.5, 3.5, so what we do? We multiply all of them by 2. So lead example, the mass of the lead. So this we will solve. And once you solve, your final answer should be C, Pb3O4.